New radio observations of the interstellar comet 3I ATLS add to the growing body of data that leaves virtually no doubt about the object's natural origin. These new findings come amid ongoing speculation about whether the object's unusual trajectory and other odd characteristics might indicate it is artificial in origin, a theory that runs counter to the wealth of evidence currently available about the comet. Recent radio observations by the Meerkat radio telescope have revealed characteristic hydroxyl absorption lines, which astronomers point to as further compelling evidence of cometary activity, while bringing In the case of the recent Meerkat observations, the molecular signatures detected in association with 3I ATLS are exactly what astronomers would expect to see typically when a comet is heated near the Sun. While the detection confirms ongoing sublimation and solar-driven outgassing, normal behavior for comets, the researchers still say continued 3I ATLS monitoring will help further assess the object's physical profile during the remaining observing time before it leaves our solar system. So, while the idea of radio signals coming from an unusual comet might sound like the kind of technosignature astronomers would hope for when searching for evidence of alien technology, it's actually something commonly seen in comets, like this one, and other kinds of celestial objects. Meerkat's recent successful detections marked the third attempt using the observatory, following efforts on September 20th and 28th, which yielded no observable signals. Fortunately, scientists will have additional opportunities to observe 3I ATLS in the coming months before it returns to interstellar space, likely never to be observed again. Next March, the comet will pass just 53 million kilometers from Jupiter, where NASA's Juno spacecraft will make further attempts to detect any low-frequency radio emissions it might produce, particularly in the 50 to 40 megahertz range. For now, however, the new Meerkat data offer further confirmation of the generally accepted scientific consensus that 3LI ATLS behaves like a comet, even if some of its behavior looks a little odd, at least compared to comets that formed in our solar system. With additional observations planned for the early months of next year, and with the object passing close to one of the best-positioned spacecraft for close-range monitoring, the search for more definitive answers about the nature of 3I ATLS and its unique composition is essentially just beginning.
Not long ago, astronomers detected a new interstellar visitor to our solar system, a mysterious object designated 3I Atlas A. This discovery ignited one of the most intense scientific debates of the decade. Estimated to be around 7.5 billion years old, this extraterrestrial body exhibits a number of strange and puzzling characteristics. These anomalies have led a portion of the scientific community, spearheaded by renowned astrophysicist Avi Loeb, to ask a provocative question. Is 3I Atlas A truly a natural comet? Or could it be a technological construct of an alien civilization? Let's try to make sense of this cosmic mystery. The entire world now watches closely as this enigmatic object continues its journey through the solar system. According to experts, 3I Atlas A has performed several maneuvers uncharacteristic of ordinary comets. After passing the Sun at a distance of roughly 203 million kilometers, its color visibly shifted from blue-green to reddish, after which it altered course toward Jupiter. These deviations from normal cometary behavior have only deepened suspicions about its possible artificial nature. Though outwardly resembles a comet, 3I Atlas A shows traits that, according to Professor Avi Loeb, director of the Galileo project and former head of the Harvard Black Hole Initiative, could point to intelligent design. Loeb, who has been tracking the object's trajectory since its discovery, proposed a bold hypothesis. One of his key observations centers on a potential Obert maneuver, a concept from astronautics describing how propulsion becomes more efficient at higher speeds. Loeb believes that 3I Atlas A's trajectory and acceleration patterns may resemble those of a craft using active propulsion rather than passive gravitational motion. He also highlights the unusually high luminosity and apparent ability to navigate between star systems, both characteristics atypical of known comets. The first recorded observation of 3I Atlas A occurred in July 2025, when Chile's Atlas observatories detected its motion. A few months later, in October, it made its closest approach to Mars. Loeb and his collaborators claim to have found the most persuasive evidence of technological origin in the analysis of the object's luminosity and gas plume composition. Using imagery from the Hubble Space Telescope, they identified an unexpected anomaly in the way sunlight scattered off the object. Normally, comets display a tail of dust pushed away from the Sun by solar radiation pressure. Yet 3I Atlas A exhibited something completely different, a glow extending twice as far toward the Sun itself. This so-called anti-tail feathering effect contradicts the fundamental laws governing natural comet behavior, since dust particles of that size should be repelled, not drawn, by sunlight. Even more baffling was the chemical makeup of the object's surrounding gas cloud. The plume contained far more nickel than iron, a ratio consistent with nickel-based industrial alloys used in spacecraft engineering. In addition, the nickel-to-cyanide ratio in the tail was found to be thousands of times higher than in any previously observed comet, including the interstellar visitor 2I Borisov. While many astronomers remain skeptical of Loeb's conclusions, insisting that 3I Atlas A is simply an unusually complex natural comet, Loeb continues to urge the global scientific community to conduct detailed observations, especially during its perihelion, the closest point to the Sun. He notes that perihelion is the ideal stage for a spacecraft to accelerate or decelerate using the Sun's gravitational energy, a principle at the heart of advanced propulsion systems. According to Loeb's model, 3I Atlas A might even serve as a mothership, capable of launching smaller exploratory probes toward Earth or other planets. The upcoming solar encounter, he suggests, will be the defining moment that reveals whether humanity is witnessing a natural cosmic wanderer or something far more extraordinary. Loeb warns against the dangers of scientific complacency, drawing a striking analogy. Just as the dinosaurs failed to recognize their impending doom, humans, too, might overlook the signs of an approaching interstellar visitor with an artificial origin. In the end, the mystery remains.
Is 3I Atlas A a rare natural phenomenon? Or are we standing on the threshold of uncovering the first evidence of intelligent life beyond Earth? As Loeb aptly reminds us with a touch of humor, quoting a famous line, "Science is like a box of chocolates. You never know what you're going to get."